Boatworks today is sponsored by Total Boat and Alexseal Yacht Coatings, as well as supported by the generosity from the beautiful folks over on Patreon. Thank you so much. Well, this is a little more normal, but it's still on the janky side. So please bear with me here. I am going to be heading back to the old shop tomorrow to pick up my regular equipment. So for right now, unfortunately, this is the best that I can do, but this is all about the content, not necessarily the quality? That doesn't sound quite right. So welcome back, everybody. Hope you're having a fantastic week. My name is Andy with Boatworks today, and this week I've got a topic that's a little bit timely, I guess is probably the best way to put it. Now, I'm not quite sure exactly what's going on in the rest of the country, but at least here up in the northern part of the States, it's hot, like gates of hell hot. So today, a little bit of a reprieve. It's only about mid-80s. But for the past week, it's been in the mid to, well, I'd say probably mid-90s, which for up here, that's hot as hell. I mean, I understand you folks down south, that's probably like, you know, shorts or winter jacket kind of weather. A little bit of a joke there. But for up here, we're not used to this. Now, whenever you're in the situation of trying to get work done in hot temperatures, that always kind of brings about some unique issues or, you know, problems that need to be solved. Now, specifically when you're working with resins, heat can be your friend, it can also be your worst enemy. And that's what we're going to be talking about today, is going to be working with resins, specifically trying to do fiberglass work when it's hot. Because we all know when it's hot, your working time with resins, well, it pretty much drops down to almost nothing. So, that said, let's get started. Now, before we jump into the meat of this video, I'm going to do a quick little overview, just because there's a lot of new people that are coming in, a lot of people that are trying to do fiberglass work for the very first time. So, quick little overview. Now, whenever we're talking about fiberglass work, you're essentially talking about sometimes using two or three different types of resins. The most prevalent or the most popular one is going to be polyester. Now, that's popular because, one, it sets up quick, which can be good and bad, but it's also much less expensive than, say, the other two options. Now, the other coming in a close second is going to be epoxies. And the third is going to be vinyl ester resin. Now, all three of these resins, they do their thing by a chemical reaction. So you add some sort of a hardener or a catalyst or a converter, and that's what cures the resin. Now, because it's a chemical reaction, that means that all three of these resins are going to be temperature sensitive. Now, what that essentially boils down to is that when it's hot, your resins set up much quicker. When it's cooler, well, it slows that down. And in some cases, if the temperature actually falls a little bit too low, well, that chemical reaction just stops altogether. Now, as we get closer to fall time, I'm going to do another video along these lines, but it's going to be dealing with trying to get this work done in cooler temperatures, because that brings along its own little host of, kind of issues and hurdles that you need to work around. But for today, just getting into summer, I'm going to be focusing on, trying to work with this stuff in hot temps, and specifically how to slow down that gel time and, try and make that work in your favor. Now, because we're talking about heat specifically, or working in hot temperatures, heat, I'm gonna break this down into essentially two different categories. Now, you can look at heat as in like the actual air temperatures, as far as, if it's a hot summer day and it's 90, 95 out, well, when the air itself is hot, that's not gonna be working in your favor. The other way that we're gonna, kind of have to work around with heat is gonna be in mass. And specifically when you're talking about dealing with, mass or volumes of resin, as that stuff starts to cure, again, because going through an exothermic reaction, the whole process becomes a little bit of a snowball effect. So if you mix up a batch and you just catalyzed it, you're going well, all of a sudden now it starts to kind of set up. Well, it gets warmer and warmer and warmer. Well, as that happens, the resin starts to cure faster and faster and faster. So tip number one is, rather than working with a single larger batch, break it down into multiples. So for example, let's just say you're working on an area where you're going to go through 16 ounces of resin, right? So it would be much better to have four 4-ounce batches, basically in the can and ready to go, rather than have a single 16-ounce batch mixed up. Now, to kind of show you kind of how much of a difference this actually makes, we're going to do a little bit of a demo. And I picked up a new little toy. All right, now for the first demo here, I'm going to be using polyester resin. And I'm going to pour out 10 ounces into one of these cups, take a temperature, catalyze it, and then I'm going to pour off 2 ounces into here, which is going to leave me with 8 ounces and then 2 ounces. And I'm going to be catalyzing the overall batch, it's just slightly under 2%. and I'll touch more on that here in a little bit. But I'm going to catalyze it to, probably 1 3/4 to, maybe pushing 2%. And then I'm going to pour off my 2 ounces. So both samples here are going to be catalyzed at the same percentage. Now, as far as what the temperature of this is right now, this is just under 82 degrees. 81.7, something like that. Now, as far as how much mech I'm going to be adding, I'm going to be doing, oh, I really need my glasses. I've got 5 cc's poured on in here. And by the way, if you're going to be doing any kind of volume mixing, one of these little bottles here is absolutely indispensable, all right? Multiple places you can get them, Jamestown, Amazon, take a look. But these things will be one of your new best friends if you're going to be doing a fair amount of layups. So I've got 5 cc's, 10 ounces of resin. Cheers. Now, what I'm going to be looking here is actual gel time, not until it's fully cured. I'm going to be looking for gel time because, well, once the resin starts to gel, you can no longer work with it. It's pretty much done. So for me, gel time is what is going to be most important here. And now, we start the timer. But this is gelled. This is pooched. Whereas 2 ounces, well, not quite. All right, so I let this material run out for 16 minutes. I just got tired and I thought it'd be kind of boring just to record that whole thing. But we're at 16 minutes now, and the 8 ounces, well, it's starting to smoke. As far as what kind of a temp we have going on here, (295 degrees). All right, so how did this all play out here? So we got the 2 ounce and the 8 ounce mixes. Now both were pretty consistent up until we got to about the 9-10 minute mark here, and hopefully this is all coming up on camera. But at around 9 minutes, all of a sudden temperature started to rise pretty quickly on the 8 ounce. At 10 minutes, at 94 degrees, the 8 ounce batch, that gelled. Now coming over here, the 2 ounce batch didn't gel until about 12 minutes. And that was at a temperature of around 84. And, well, looking at these numbers here, you can look how quickly, once that reaction starts, how fast the numbers climb. So here's the 8 ounce column. Went from 103 to 111, 128, 176, and then right up to 295 where it was smoking. As that compared to the 2 ounce mix, went from 86, 96, 104, and then finally it looks like it peaked at around 128. So what was the takeaway here? Well, basically the smaller batch gave you an extra 2 minutes of working time. So right now you may be thinking, well, the hell is 2 minutes? What kind of difference does that make? Well, 2 minutes can make the difference between finishing the layup that you were working on versus not. And if you're halfway through a layup and you don't have the entire section wet out, and this stuff gels up on you, you're pretty much having to peel all that back off and start over. That's not good. So that extra 2 minutes, while though it may not seem like much, can be huge. All right, so let's just kind of take this one step further here, and let's kind of presume that you're working on an area where you don't want to deal with having, say, 16 little cups of 4 ounces each. Don't you worry, we got you covered. Now, there's a second way, this will be tip number 2, that you can kind of cheat this. Now, you can still mix up a big batch. The trick is you can't leave it sitting in the cup, right? So if you wanted to, mix up a batch, say it's 16, 32, or 64 ounces, it doesn't matter. The volume is irrelevant. But you're going to go through all that material in a single application. You can mix up your large batch, but the trick is as soon as it's catalyzed and it's well stirred, obviously you need to get the catalyst incorporated well into the resin. But once you've got that done, rather than leaving it in the cup, pour it out over the fiberglass that you're going to be working on. Now, obviously, this works better if you're going to be working on a horizontal surface. Now, you can still kind of cheat this a little bit. You need to find a little bit of a compromise. Now, if you're going to be working on a vertical surface, you can still kind of cheat it by pouring it out into a paint tray. A paint tray is going to cover a hell of a lot more surface area than this little cup. So, rather than, say, mixing up, say, 64 ounces, maybe mix up 32 ounces and pour that into your mix or your paint tray. Now, by spreading it out into a thinner layer, right off the bat, you're essentially, oh wow, you're essentially accomplishing the same thing as what we did here. If you go ahead and you mix it, you pour it out, now your resin is in a thin layer versus a thick layer. You're going to have that same kind of a working time difference. And again, in this particular situation, in these temps, and right here in the makeshift shop, it's about 82 degrees. So to kind of use that as a reference, now the warmer it's going to be, the warmer your air temps are going to be, the shorter your working time is going to be. But on the other flip side of that coin, the cooler the temps, the longer working time you're going to have. So tip number one, mix up multiple small batches. Tip number two, if you have to deal with a larger batch, catalyze it, pour it out into a thinner layer, whether it's in a paint tray or actually on the work surface that you're going to be wetting out. Now, tip number three might ruffle some feathers a little bit, a little controversial. Maybe not. I don't know. I mean, I've been doing this way for years when I needed to. But taking a step back and remembering that poly resin, it's just like epoxy. It is temperature sensitive. So if you need to get a little bit more working time, well, kind of an obvious thing to try is just to actually lower the initial or starting temperature of the resin to begin with, right? Now, polyester resin, minimum temps that you should be working in without any outside influences, which I'll be talking more about that in the fall time when we're talking about, trying to work with resins in cold weather. But generally speaking, when you're outside in the sun, air temperature, that kind of a deal. The absolute minimum working temperature for polyester resin is generally considered to be about 60 degrees Fahrenheit. Now, when I'm talking about artificially lowering that temperature, I'm not talking about freezing it. Now that would be bad. No resin likes to be frozen. But as long as you're able to lower it kind of below that threshold of where the chemical reaction wants to start happening, you're all right. Lower it down, mix in your catalyst, and then go ahead and start working with it. Now, as you're working it, spreading it out, that temperature, because the air is going to be warm, is going to continue to rise. Now, once it gets to that certain threshold of about 60-ish degrees, the chemical reaction is going to start. And things are going to basically continue on or progress the way that they should. Now, when I'm talking about lowering that temperature, I'm not talking about freezing it. So if the chemical reaction starts initially around 60 degrees, I'm referring more to bringing it down to, like, say, maybe 50, possibly 45, but bringing it down to there, getting your catalyst mixed in, and then starting to work with it is going to extend you that much more working time until you get up to that 60-degree mark. The reaction starts, and then temperatures are going to start to decline as that exothermic reaction starts to occur. Now, just to kind of show you what kind of a difference cooling this resin is going to make, we're going to do one more quick little demo. I'm not going to do an 8 in a 2-ounce batch. I'm just going to do the 2-ounce batch and compare that to what we just went through here. I'm going to catalyze it at the same percentage, about 1.75%. Except when I cool this, I'm going to stick this resin in the fridge before I catalyze it. Now, I would not recommend doing this because everything in your fridge is going to stink. All right. What I would recommend though is maybe taking the resin and, while you're doing some other things for, say, 5, 10, maybe 15 minutes, put it into a cooler that has some ice. That way the ice itself, it's impossible for it to bring that resin below 32 degrees, probably closer to 34, 35-ish. which is going to be a little bit cool if you were to leave it in there for that long. But like I said, put it in a cooler with some ice, leave it there for 5-10 minutes. And if you have one of these little infrared thermometer temperature laser thingamajiggers, check it. I mean, I wouldn't push it much below, say, 50, maybe 45 degrees before you start to catalyze it and work with it. So let me get another batch mixed up, and then we're going to let this thing run and time that and see how much longer working time we get compared to the 2-ounce batch that we just did starting at ambient temperatures. At least everything in here is frozen. All right. Okay, so initially we were at 81 degrees, I believe. Right now we're down to about 50, give or take. All right, so now I'm going to go ahead and catalyze this at around 1.75% cc's, and well, we'll just mix it up and let the timer run and see how it goes. Now you can see the viscosity. I mean, it is slightly thicker, but it is not thick. It's just slightly thicker than when it was at ambient temperature. So I'm going to go ahead, because it is a little bit thicker, I'm going to give this a very thorough mixing for probably at least a minute, because this is just, 2 ounces. Now, if you're going to be doing this with a larger batch, you may want to mix it for, I don't know, maybe 2, maybe 3 minutes. And one other tip I just realized, and this is something that I learned a long time ago the hard way. You see how I'm holding this? My hand is hot. So by holding it like this while I'm stirring it, I'm actually heating this cup up faster than if it were just sitting on the surface. So let me change that. Okay, 25 minutes. We have a finished temp of 82 degrees. And this resin is gloppy. It's gelled. Oh, you know what? There we go. So cooling the temperature down, our starting temperature, made a significant difference. It basically gave us double the working time. Now again, just want to stress this enough. When you're working with the, and right now I'm referring specifically to poly resin, you don't want to freeze this. Freezing will, on a chemical level, I don't know what it does, but it pooches it, all right? You cannot freeze it, and I wouldn't go anything cooler than, say, 45 absolute maximum, or coolest. But I think we started here, I don't remember, I'll have to look through the video here, but I think we started around 50 degrees, and we got to 25 minutes of gel time compared to the first time when we were starting at ambient temperature. We had 12 minutes of gel time. So literally twice the amount of working time. Now, there's still one more variable that can be played with here to even get more working time. We were catalyzing this, or I was catalyzing this around 1.75%. Now, poly resin can be catalyzed between 1 and 2%, somewhere within that range. So if we were to actually take that and catalyze it at 1%, this whole reaction would have gone even slower. I don't know that it would be twice as slow, but it would be significantly slower. So that makes a huge difference. Now, I understand that, there's a lot of different variables that kind of come into play here as far as temperature of the air, starting temperature, the percentage of catalyst that you add, that kind of thing. Now, for anybody that's going to be starting off, or trying to do a repair like this for the first time, and it doesn't necessarily apply strictly to this laminating resin that we're using for fiberglass. This would also apply to gel coat, because gel coat is a polyester-based material. If anybody is looking to get started on a project for the first time and you're not quite sure where to start, I do have a downloadable guide available on my website. I'll include a pop-up link for it up here in the screen, as well as links down below in the description. If you're really not quite sure where to start and all this is just seeming a little bit overwhelming, this guide will answer a lot of your questions, and it'll get you started in the right direction, at least getting started on the right foot. So again, I'll include links for that up above as well as down below. I've had a lot of people download this, and every single person has said that this has been a huge help. So check it out. If you already understand this, good on you. If you're looking to get started and you have a bunch of questions, that is a great place to start. All right, so now up to this point, we've been talking specifically about polyester resin. Now, we haven't really touched on epoxy. However, a lot of things that we covered with polyester resin are very applicable to epoxy as well, but there is one more slight little variable that it can give you a little bit of an added edge. So now, here, looking at the Total Boat line of epoxies, now I typically tend to use their 2-to-1s, but they also have 5-to-1s. The hardeners and the way that they're mixed and I believe, I can't say this for 100%, but I believe the rate at which they start to cure is pretty comparable between the 2-to-1 and the 5-to-1. The variable that we have with epoxy that we do not have with polyester resins is that you have multiple types of hardeners. So here is their base resin. Again, I'm using their 2-to-1, but they also make a slow, a medium, and a fast hardener. Now, how does this come into play? Well, typically if you're working in cooler temps, you can gauge the hardener to the temperature that you're going to be working in. If you're going to be working in cooler temperatures, say like 50 degrees, you're going to want to use the fast hardener. If you're going to be dealing with hot temperatures, 90s or more, you're going to want to use the slow. Somewhere in between, you can use the medium. But you can gauge the hardener to the temperatures that you're working in. If you'd be curious to see what kind of working times you can get out of these different hardeners, let me know. I can queue that up for next week. Again, not making excuses, but I am trying to make do with the situation that I've got right here, given the shop and the transition we're in the middle of. So this is something that I can very easily do. If that's something you'd be interested in seeing, let me know. Leave a comment down below. I should mention one thing. Now, with polyester resin, I said that you can adjust how it's catalyzed, so you can do it between 1% to 2%. With epoxies, there is no wiggle room with how it's catalyzed. I mean, you have to catalyze it the way it's designed to be used. So if you're using a 2-to-1 epoxy, you're going to use 2 parts of the resin to 1 part of the hardener. Same thing would apply if you're going to be using a 5-to-1 or a 3-to-1 epoxy. Those ratios cannot be messed with, all right? You have to stick to that. But you can kind of bend that curve a little bit with the hardener that you decide to use. And on that note, I think I'm gonna wrap this up. So as always, I hope you enjoyed this video. I hope you found this very, very helpful. And if you did, hit that thumbs up button. If you're not already subscribed, hit that subscribe button and the notification bell. Thank you in advance. I really appreciate that. If you have any questions, comments, please leave those down below. I'll be happy to look those over and address them the best I can. And as always, I guess thank you for your time. Thanks for watching, and I'll see you next week.
This has been a Boatworks Today production.